Welcome to all of you in Sankalpa Education Pratham classes. I am Sachin Patil, delivered lecture series related to rotational dynamics. Right now we are going with rolling motion. Rolling motion, when any cylinder, any sphere or any wheel, it is performing a rolling motion in a pure rolling motion, in pure rolling motion, in pure rolling motion, two motions are simultaneously undertaken as circular motion. In circular motion, the particles of the body are performing circular motion about that axis. Circular motion about, I'm taking inside the bracket is here, about symmetric axis, and rolling motion, rotational motion. It is about center of mass, center of mass is here. What does it mean? When let us consider, when body is performing a rolling motion, at that time it having two types of motions. One is a linear motion. Here I am taking the rotational motion is there. It is a linear motion and circular motion. At that time, first of all, body is rotated, or it is performing the circular motion about the asymmetrical axis. When we know that the wheel of motorcycle perform the circular motion about the axis, and its axis or motorcycle moving forward. At that time, the rolling motion of motorcycle wheel perform two types of motion. One is a circular motion about the axis of symmetry, and another is a linear motion about the center of mass. That means axle or vehicle or motorcycle moves forward, you will get the linear motion, and particles of the tire moving in a circle, that means it gives a circular motion. And therefore rolling motion, it is a combination of rolling motion undertaken two types of motion. It is a circular motion and linear motion also, and therefore you can say that linear circular motion. Therefore you can say that objects, any object perform rolling motion possesses two types of kinetic energies. That means you will get the rotational kinetic energy and translational. As that of rotational kinetic energy and translational kinetic energy. What does it mean? That means due to circular motion of a body, you will get the rotational kinetic energy, and due to linear motion of a body, you will get the translational kinetic energy. And therefore rolling motion is a combination of circular motion and linear motion. Therefore it possesses a rotational kinetic energy as well as a translational kinetic energy. Now consider object have I be the moment of inertia, V be the linear speed, linear speed or linear velocity of that one. R be the radius of body, omega angular speed or angular velocity is there. Then m mass of the body, and k is radius of gyration is there, radius of gyration. Then according to that one, I is equal to m k square is there. We know that about the consideration of radius of gyration, and radius of gyration is okay. At that time, moment of inertia is equal to mk square is there, and therefore you will get the consideration of I, moment of inertia, v linear speed, r is the radius of body, omega is the angular speed, m is the mass of the body, k is the radius of gyration, and therefore total kinetic energy of rolling body is equal to translational kinetic energy plus rotational kinetic energy is there, and therefore this energy E is given as 1/2 m v square plus 1/2 I omega square. We know that the mass and moment of inertia are analogous quantities, and therefore m is replaced by I. You will get the rotational kinetic energy. V is replaced by omega. V is a linear velocity and omega is a angular velocity. Therefore V and omega are analogous quantities are there. Right now we know that I is equal to mk square is here, and therefore you will get the consideration of 1/2 m v square plus 1/2 m k square, 1/2 m k square into omega is nothing but what? Omega is nothing but we know that the omega is equal to v into r. Therefore v divided by r square is there. And by using this consideration, you will get the consideration of 1/2 m v square. Now we have to take the common things here. 1/2 is there, m is there taken outside, and v square is here. You will get the consideration of inside the bracket 1 plus k square divided by r square. This is your kinetic energy of rolling body is there. We remember that first of all here static friction is most important for the rolling motion. Static friction important for rolling motion, and it prevents the sliding. It prevent the sliding motion, because we know that the sometime when a body is start to roll, and after some time it slide on the surface, and at that time it not remain as a pure rolling motion, and sometime any body is start first of all when we have to push it, at that time it is a slide on the surface, and after that it is a start the rolling, and at that time it is not a pure rolling motion. And therefore static friction is most important related to prevent the sliding of the body, and you will get the pure rolling motion, and in pure rolling motion you will get the total kinetic energy of rolling motion is a combination of that translational as well as rotational kinetic energies. Now we are going with a consideration of linear acceleration and speed while pure rolling down on inclined plane. later to consider when body is rolled down from the inclined plane. Later to consider this is an inclined plane with a horizontal. That means you are start from here and reaches to that position. Later to consider this is the distance between these two positions. S is the distance between these two positions, and theta be the angle of inclination. Later to consider m be the mass of that object, r be the radius of that object. The radius of that object is r, and it is rolling down inclined surface with angle theta. Theta is the angle with a horizontal surface making by that inclined surface, and object start to roll. We know that when any body is start from a static one, at that time its gravitational potential is converted into kinetic energy. Gravitational potential energy is converted into its kinetic energy. You can consider V be the velocity, or speed of object when the body is comes from here to here. That means velocity of body is v here, and the starting velocity of that body is later to consider u be the starting velocity is here is 0, and when this body is comes at that position, the velocity of body is v here, and therefore when body performs a rolling motion and it comes from this position to this position, at that time the potential energy of that body is converted into kinetic energy of at this position. And therefore first of all we know that when a body is rolled down or rolling, at that time it having the circular motion as well as a translational motion, and therefore kinetic energy of rolling object E is equal to kinetic energy of rolling object E is equal to, we know that it is a combination of kinetic energy of translational motion and kinetic energy of rotational motion, and by using this one we will get the consideration of 1/2 m v square inside the bracket 1 plus k square divided by r square is here. And we know that this kinetic energy of rolling object is nothing but it is a conversion of gravitational potential energy. We know that the body is at height h. The body is at height h, and therefore potential energy is nothing but it is obtained due to the position of the body, and therefore the position h be the height of that body and m be the mass of that body. Then you will get the potential energy or gravitational potential energy is equal to mgh, and this mgh, that means gravitational potential energy, is converted into kinetic energy, and therefore you can say that kinetic energy gravitational potential energy is equal to kinetic energy of rolling body or rolling object is there, and therefore you will get the consideration of mgh is equal to, because gravitational potential energy is mgh, is equal to kinetic energy of rolling body, that means 1/2. That means you will get the 1/2. Later to consider there is a m with the capital M is here, and by using that capital M, mass of the body or mass of the object is considered as capital M, because inside this equation you will get the M be the mass of object, and therefore mgh is equal to 1/2 m v square inside the bracket 1/2 k square divided by r square is here. And right now we have to cancel out this m, and this m is here, and 2 is transferred here. You will get the consideration of v square is equal to 2gh divided by 2 is transferred here, that means 2gh, and this multiplied here and it is divided. You will get the consideration of 1/2 k square divided by r square, and it implies that when we taking the square root on both sides, that means you will get the v is equal to 2gh divided by 1 plus k square divided by r square is here. 1 plus k square divided by r square is here, And by using this you will get the consideration of this is the formula for linear speed, or this is formula for linear speed while rolling down on inclined plane. That means v is equal to square root of 2gh divided by 1 plus k square divided by r square. It is a linear speed of the body when it is rolling down from the inclined plane is there. Right now we know that the consideration of according to kinematical equation, what you can say, first of all we have to get the consideration of v square is equal to s square, v square is equal to u square plus 2as is here, and therefore it implies that v square minus u square is equal to 2as, where a is the acceleration, s is the displacement. Yes is the displacement, and therefore you can get the consideration of 2as is equal to v square minus 0 square is here, and it implies that v square is here, and therefore 2as is equal to v square, because u is the initial velocity and we know that the initial velocity is equal to 0 is here, and putting those value you will get the consideration of 2as is equal to this one. But we know that the v square is equal to 2gh divided by 1 plus k square, and putting this value you will get the consideration of here. It implies that 2as is equal to 2gh divided by 1 plus k square divided by r square is here, 1 plus k square divided by r square. First of all you have to get the consideration of this one. Right now from the figure, once again I am going towards the figure, and from figure you will get the consideration of this is the theta, this is the opposite side, this is the adjacent side, and this is the hypotenuse of that one. Hypotenuse is equal to s, and this is the opposite side is h, and therefore from the consideration of sine theta is equal to opposite side h divided by hypotenuse is s. S is multiplied here, divide here, and therefore it becomes a multiplied here. Therefore h is equal to s into sine theta is here, and by putting this value of h is equal to s into sine theta, you will get the next consideration related to that. Now we get that, but here h is equal to s into sine theta from figure. Putting this value inside the equation, you will get the consideration of 2as is equal to 2g, h is equal to s into sine theta divided by 1 plus k square divided by r square is here. Right now s is cancelled out, 2 is cancelled out, and therefore a is equal to g into sine theta divided by 1 plus k square divided by r square is here, and this is your value related to the acceleration. This is linear acceleration while object rolling on inclined plane, is here, and you will get the pure sliding is there, and without friction you will get the acceleration is equal to g sine theta, and final velocity is equal to pure acceleration, pure sliding without friction. You will get the consideration of this related to that one, and here effective factor is nothing but 1 divided by 1 plus k square divided by r square is there, and this effective factor in both expression considered, because we know that the velocity is equal to square root of 2gh divided by 1 plus k square divided by r square. What you can say, I am repeated it here. V is equal to square root of 2gh divided by 1 plus k square divided by r square. That means 1 plus k square divided by r square, 1 plus k square divided by r square. It is effective factor in both cases, and it is effective factor in both cases, and therefore you will get the consideration of for sliding motion, pure sliding without friction. At that time you will get the consideration of this effective consideration of this effective value inside the both, and therefore you will get the actual value of acceleration is nothing but g sine theta, and actual velocity v is equal to square root of 2gh, and this is the effective factor which makes some difference, which gives the same concentration, same changes in the acceleration and velocity here. And from this you can get the remarks related to that one as follow. Now first remark is nothing but what if moment of inertia of the form n into mr square, that means mr square is there and n is multiplied to that mr square, at that time k square divided by r square is equal to n. How it is possible? For example, you have to consider moment of inertia is equal to 2 divided by 5 mr square. It is a moment of inertia of solid sphere is here. This is the solid sphere, moment of inertia of solid sphere is there, and by using this example here, n is nothing but this 2 divided by 5. N is nothing but this 2 divided by 5. That means n is equal to 2 divided by 5 is here. N is equal to 2 divided by 5 is here. And our remark is what? If moment of inertia is in the form of n into mr square, that means n into mr square is here for solid sphere. At that time you will get the k square divided by r square is equal to n. How it is possible? 2 divided by 5 mr square is equal to, later to consider mk square, because k is the radius of gyration. At that time mk square is here, and you transferred this, m is cancelled to m, and r square is multiplied here, it is taken divided here. At that time it implies that k square divided by r square is equal to 2 divided by 5, and 2 divided by 5 is nothing but n is here, and therefore this is your consideration. For ring, we know that the I is equal to mr square. It is for ring is there, and here n is nothing but a 1. N is equal to 1, and therefore you will get the consideration of mr square is equal to mk square, and therefore m cancelled here, r is multiplied, divided here, you will get the implies that k square divided by r square is equal to 1 is here. That means 1 is nothing but your n, and this is your first remark related to that one. Now second remark related to that one, while body is rolling, at that time ratio of translational kinetic energy, rotational kinetic energy divided by r square as to 1 plus k square divided by r square. For example, you have to consider, right now you will get the consideration of for solid sphere, k square divided by r square is equal to 2 divided by 5 is here. K square divided by r square is equal to 2 divided by 5. Now putting this value inside this one, you will get the consideration of 1 as 2 divided by 5 as 2, 1 plus 2 divided by 5 is here. 5 into 1, 5 plus 2, 7 divided by 2, and therefore it implies that 1 as 2 divided by 5 as 2, 7 divided by 5. 7 divided by 5, and from this you will get the consideration of, it implies that 5 as to 2 as to 7 be the ratio of translational kinetic energy, rotational kinetic energy, and total kinetic energy for the solid sphere. Similarly, you can perform the consideration related to ring, rod, disk and so on. So you will get the consideration of this consideration like that one. We know that for disk moment of inertia for disk moment of inertia is 1/2 mr square is there, and therefore k square divided by r square is equal to 1/2 is there. K square divided by r square is equal to 1/2 is there, and therefore the ratio is 1:1/2 plus 1/2. It implies that 1:1/2 3 divided by 2. And you will get the consideration of this implies that 2:1:3 is here. This is the kinetic this is the ratio of translational kinetic energy, rotational kinetic energy, and total kinetic energy related to that one. These are the remarks related to your moment of inertia in the form of your consideration, and you will get the consideration of that remark related to that one, and you will get the linear acceleration and angular acceleration related to your body is sliding or rolling from the inclined plane is here. If you like this video, please subscribe my channel and press the bell icon to get the next notification related to rotational dynamics lecture series. Thank you.